Okay, welcome viewers. So in this video lecture, we want to count total number of reflexive relations and total number of symmetric relation. Okay. Now, uh, first of all, let me remind you that what is a reflexive relation. So suppose that if we have this set 1, 2, 3, okay, and we define a relation on this set like 1 comma 1, 2 comma 2, 3 comma 3, 1 comma 2, and 3 comma 1, suppose. Okay, then see, as we have 1 in a set, we have 1 comma 1 in the relation, it is okay. We have 2 in the set A, so we have 2 comma 2 in the relation, it is okay. If we have 3 in the set, then we have 3 comma 3 in the relation. Okay, so it means that whatever elements you have in the set A, okay, then their same ordered pair, it should be inside the relation. Okay, we may have other elements also, like this element and this element. Okay, but this is the minimum requirement that elements of same time, they should be inside the relation. Okay, rest of the elements, they come or not, okay, it doesn't matter, but this is the minimum requirement for any relation to be a reflexive relation. Okay, so you people keep this thing in your mind. Now we solve the question that how many reflexive relations are there, okay, on a set having n elements. Okay, so how many reflexive relations are there in a set having n elements. Okay, so solution: consider a set A having n elements. Okay, suppose that we have this set A in which we have n elements. Okay, like this. Then you see that number of elements in A cross A are given by this table: 1, 2, up to so on, and 1, 2, up to so on, and okay. If you take the cross product of these elements, then this first element here, it becomes 1 comma 1, 1 comma 2, and so on, 1 comma n. Next is 2 comma 1, 2 comma 2, and 2 comma n. Okay. Next one is n comma 1, n comma 2. Next one is n comma n. Okay. Now number of elements in A cross A. See, these are equal to n cross n. Okay, because in set A we have n element, in set A again we have n element. So n cross n means we have n square elements. Okay, so it means that these are these are from here to here. Okay, these are n square elements. Okay, these are n square elements. Okay, now next you count the elements on the diagonal. Okay, so on the diagonal we have these elements. Okay, now number of elements on the diagonal, these are what? These are n. Okay, these are n elements. Okay, now so it means that number of off diagonal elements, number of off diagonal elements are n square minus n. By off diagonal I mean that count the number of elements which are not the diagonal element. Okay, as you have total n square elements, out of these n square only n are on the diagonal, so it means that number of off diagonal elements are n square minus n. Okay, now we want to count number of reflexive relation. Okay, number of reflexive relation. Okay, see, as our relation is reflexive, so these elements 1 comma 1, 2 comma 2, and n comma n, these should be present inside the relation. Okay, so for these n elements I have only one option. Okay, I have only one option for these elements because I always have to include these elements in my relation. Okay, so I am multiplying here 1 n times. Okay, but for the other elements which are not the diagonal element, okay, I have two options for them. Okay, how? I may write this element in my relation, or I may not write this element in the relation. Okay, still the relation remains the reflexive relation, because the condition for the reflexive relation is this, that only these elements they should be inside the relation. Other elements they come or not, it doesn't matter. Okay, so for this element I have two options. Okay, for the next element again I have two options. Okay, so for similarly for this element again I have two options. Okay, so for these off diagonal elements I have two options. Okay, so how many off diagonal elements do I have here? I have n square minus n off diagonal elements. Okay, so I am multiplying them n square minus n times. Okay, so this is equal to 2 raised to the power n square minus n. Okay, so this is a very important result. Okay, using this result we can tell that how many reflexive relations are there. Okay, so the formula is this 2 raised to the power n square minus n. Okay, now we solve one question based on this. So the question is this: if in a set we have three elements, then count the number of reflexive relations. Okay, so solution: number of elements in set A, these are equal to 3. Okay, now what is the formula of number of reflexive relation? Formula of number of reflexive relation is 2 raised to the power n square minus n. Okay, where this n represents the number of elements of set A. So this is 2 raised to the power 3 square minus 3. Okay, 2 raised to the power 3 square is what? 9. 9 minus 3. So 9 minus 3 is what? 6. So 2 raised to the power 6 is what? 64. So it means that in a set where we have three elements, the total number of reflexive relation which we can form are 64. Okay, So this is how you can solve any question of total number of reflexive relation. Okay. Now next we want to count number of symmetric relation. Number of symmetric relation. Okay. That how to count total number of symmetric relation. Okay. I remind you the definition of symmetric relation, that a relation R on a set A is called a symmetric relation if AB is the member of R, then B comma A, it should be the member of R. Okay. If AB is the member of R, then B comma A, it should be the member of R. For example, if we have this set and here I take this relation 1 comma 1, 1 comma 2 and 2 comma 1. Okay. Then you see that if you have 1 comma 2 element, then this element has to be present in the relation if this relation is a symmetric relation. Okay. So if we have 1 comma 2, then 2 comma 1, it should be inside the relation. Okay. This is mandatory for any relation to be a symmetric relation. Okay. Now next we count total number of symmetric relation. Okay. So counting of number of symmetric relation. Okay. So question is this: consider a set n having n elements. Find total number of symmetric relations. Okay. So solution: number of elements in set A, they are equal to n. Okay. And suppose that in this set A we have these types of elements n minus 1 into n. Okay. So in A cross A, you see that what type of elements do you have? List the elements of set A, 1, 2, up to so on n minus 1 into n, n minus 1 and n. Here also list the elements 1, 2, up to so on n minus 1 and n. Okay. So what is the first element? 1 comma 1. What is the second element? 1 comma 2. What is the next element? 1 comma n minus 1. What is the next element? 1 comma n. What is the next element? It is 2 comma 1. Next element is 2 comma 2. Okay. Next element is 2 comma n minus 1. Next one is 2 comma n. Okay. Likewise, here it is n minus 1 comma 1. Okay. N minus 1 comma 2. Here it is n minus 1 comma n minus 1. Okay. And n minus 1 comma n. Next one is n comma 1. Next one is n comma 2. Next one is n comma n minus 1. Next one is n comma n. Okay. Now, as we want to number of count number of symmetric relations. Okay. Now, suppose that we take this element. Okay. Now, if we take this element 1 comma n, okay, then for this element I have two options. I may write this element in my relation, or I may not write this element in my relation. Okay, so for this element I have two options. But once I write this element in my relation, okay, then this element is bound to come automatically. Okay, because the relation is symmetric relation. Okay, so for this element you have two options. Okay, and for this element you have only one option. Okay, because when this element comes in the relation, then this automatically comes inside the relation. Okay, now similarly for this element, okay, again you have two options, whether you can write this element in your set uh, of relation, or okay, or you may not write this element in your relation. Similarly for this element, again you have two options, but once you select this element, okay, then this element also comes in the relation automatically, and if you select this element, then this element it automatically comes in the relation. Okay, so I have two options for this and two options for this. So 2 into 2, it is what? It is 2 square. Okay, likewise for the next one I have two cube options. Okay, so on the diagonal we have 2 raised to the power n options. Okay, so therefore see the elements which are the below the diagonal element, okay, they automatically come in the relation. Okay, so here total number of reflex symmetric relation are 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, and it is 2 raised to the power n. Okay, now as basis same power added, so you can write it as 2 raised to the power 1 plus 2 plus 3 up to so on n. Okay, now this is this is equal to 2 raised to the power summation n. So this is the compact form of counting total number of symmetric relation, but this can also be expressed like this: 2 raised to the power summation n mean n into n plus 1 divided by 2. Okay, so you people remember this formula, that total number of symmetric relations, they are always equal to 2 raised to the power n into n plus 1 divided by 2. Okay, now we solve one question. Question is, uh, if in a set we have 5 elements, then find number of symmetric relation. Okay, then find number of symmetric relations. So solution: number of elements in set A, they are equal to 5. Okay, now number of symmetric relations, these are equal to 2 raised to the power n into n plus 1 divided by 2. So it is 2 raised to the power 5 into 6 by 2. So it is 3. Okay, 5 into 3 is what? It is 15. So 2 raised to the power 15 is the answer. Okay, so in this way you can solve these types of numerical problems. Okay, now next we want to talk about irreflexive relation. Okay, what is irreflexive relation? A relation R on a set A is called irreflexive relation if A comma A, it is not the member of relation for all A belonging to the set A. Okay, mean we do not want same ordered pair inside our relation. Okay, for example, Suppose you have this set 1 2 3, and suppose you have this type of relation 1 comma 2, 2 comma 3. Okay, uh, so you see that we do not have 1 comma 1 in this relation. We do not have 2 comma 2 in this relation. We do not have 3 comma 3 in this relation. Okay, so that is why this relation is a irreflexive irreflexive relation. Okay, now see one more example. Suppose you take this relation 1 comma 1, 1 comma 2, and 2 comma 2. Okay, so you see that as 1 comma 1, okay, it is the member of the relation. Okay, so this relation is not a this relation is not a reflexive. Okay, this is not a reflexive relation. Okay, because we have same type of ordered pair inside the relation. So this is a reflexive relation. Now next we want to talk about asymmetric asymmetric relation. So a relation let me take another sheet. Okay, now we talk about asymmetric relation. Okay, so what is a asymmetric relation? A relation R on a set A is called asymmetric relation if A comma B it is the member of relation, then B comma A it should not be the member of the relation. Okay, if A comma B it is the member of relation, then B comma A it should not be the member of relation. For example, suppose we have this set 1 2 3, and we have this relation 1 comma 2 and 1 comma 3. Okay, so you see that as you have 1 comma 2 in the relation, but you do not have 2 comma 1 in the relation. Okay, and here we have 1 comma 3 in the relation, but we do not have 3 comma 1 in the relation. So that is why this relation is asymmetric relation. Okay, now see the another example. Suppose you take this relation 1 comma 2 and 2 comma 1, 1 comma 3. Okay, so see as 1 comma 2 it is the member of relation, but also 1 comma 2 comma 1 2 comma 1 it is also the member of relation. Okay, so here this condition is violated by this relation. So that is why this relation is not asymmetric 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 relation. Okay, so thank you very much viewers for watching this video. More about it will be discussed